In this video, we are going to look at what normalization of a database is and how to do it. You have worked with databases for a while now, but let me clarify a few things here. This is a photograph of a number of slips. There's lots of data on those slips. I suppose you could call this a pile of data, but this is not a database. We can turn this into a database by ordering and structuring the data so that we can retrieve information easily. Imagine the amount of work you would have to do to find a specific item of data in this pile. However, this is typically what inspires us to create databases. We have source documents, these slips, and from them we need to retrieve data quickly and easily. For this video, I'm going to assume that that pile of slips all had different pieces of data about students registering for courses at SSir online school and their marks. If I turn this into a database, then my first attempt using some of the data might look like this. I have analyzed the slips and come up with this structured and organized format. You can see, for example, that I have chosen some headings, some column headings, or fields in a database. The name of each student, the subject of that student, the subject description, and each student has at least a mark for the first subject that they do. And you can see that Cleopatra Rex does more than one subject. She does history and drama, and she has marks for both of those. So this is a database because it is structured and organized. It will be a lot easier to find a piece of information in this database than going through the piles and piles of paper. The rows are called records in the table, and each of the columns is called a field in the database. Even though this database, which is now in electronic format, is a lot easier to find a certain piece of information or to extract or retrieve some details out of the database, there are still some problems. For instance, you can see that both Cleopatra and Obelix do history. So, if for some reason the code for history changes, then this code will have to be fixed or updated in more than one position in this database, and our database only has 3 records. Imagine if we had thousands of records, then we would have to firstly find all the occurrences of the word HIS in this database and replace each of them accurately and correctly and not miss any of the occurrences. Because we have to update things in more than one place, this could lead to errors. And this type of problem is called an update anomaly. Normalization is the solution to this problem. Normalization gets rid of update anomalies as well as the other 2 anomalies which we'll talk about now. The next type of anomaly would be a delete anomaly. If I wanted to stop teaching a certain subject, for instance, we might as well stick to history. If I wanted to stop teaching history, then I will have to delete every record in which history occurs. That means I will at least delete these 2 records, the Cleopatra record and the Obelix record. But it does mean that I will delete the student, Cleopatra, her marks, and her other subject. In other words, I'm deleting too much information, and that's because I cannot get rid of history in this table without deleting the records in which history appears. That is a delete anomaly. And once again, normalization helps us to get rid of these. The last type of anomaly I want to talk about is the insert anomaly. And that is when I want to start adding data, but my structure of the database prevents me or makes it difficult. So for instance, if we wanted to start offering a new subject, but we don't have any students in it yet, then this structure would make that very difficult. I cannot merely add a subject such as, for example, AP Maths, because I would have to add the name of a student and the description of that subject and marks as well. So this is called an insert anomaly, and once again, normalization helps us to get rid of it. Because these are important concepts, I want to go through them again. An update anomaly occurs when an item of data changes and then has to be altered in other records too. An insert anomaly happens when We cannot merely add new data because the structure of the database prevents us. So in this case, the example I gave was if we wanted to add a subject such as AP Maths, I would have to add students as well. And then we spoke about a delete anomaly, which occurs when deleting one piece of data results in the removal of other unrelated data. So let's look at what is normalization. It is the process of efficiently organizing data in a database to prevent repetition and to ensure easy queries and reports. This means that we only want to store related data in a table and we don't want to store the same data twice. We normalize a database in stages. The first stage would be first normal form. Once we've put the whole database into first normal form, we change it into second normal form and finally into third normal form. There are higher fourth and fifth normal forms as well, but that's outside the scope of this course. So our goals for normalization are that we want to increase the accuracy of our database, eliminate redundancy, that means data that is stored more than once. We want maintenance to be done easier, we don't want any anomalies, and we want our queries to run smoothly and accurately. So let's look at first normal form, second normal form, and third normal form. The rules for first normal form are to remove firstly any repeating groups. The result, of course, is that we rather have redundant data in rows than repeating groups or columns. We must also remove any non-atomic data, and each table must have a primary key. So in our example, I've reduced the number of records in my database to just 2 because it is sufficient for my explanation this time round. Look at this table. You can see that asterisk minor takes a subject, a single subject, English, and it has a description and a mark and a symbol. However, Cleopatra takes 2 subjects, and these columns, subject 1 and subject 2, seem to be very similar. Description 1 and description 2 are once again very similar. This is an example of what I mean by repeating groups. Now, if you look at this second table that I put over here, it is merely a different way of writing the exact same table with repeating groups, but written in a different way. So asterisk still has only one subject, but Cleopatra now has her 2 subjects, but the repeating groups are slightly more disguised. Now history and drama appear in the same field, and the marks appear in the same field, and the symbols do, and the descriptions do. But you should be able to see that it's very easy to rewrite this format into this first format that we used over here. And here the repeating groups are clearly visible. Subject 1, description 1, mark 1, this should be symbol 1. These headings are effectively repeated in these 4 columns. So how can we remove them? Let's look at this table over here. I have increased the number of lines, the number of records therefore in this database, in order to reflect the same data as in these 2 tables, but with no repeating groups. So you can see that in this table I have only subject 1, description 1, mark 1, and symbol 1. As a matter of fact, I could have called this subject, description, mark, and symbol, but I have added a third row. And this third row is now redundant data. I have Cleopatra Rex in it again, and I have a subject and a description and a mark and a symbol. But redundant data is better than repeating groups. And that's a prerequisite for first normal form, that we get rid of repeating groups. So we've achieved one of the steps of first normal form, and that is to remove repeating groups, even though we end up with redundant data. Before we do the next step in first normal form, or in achieving first normal form, let's look at primary and foreign keys. A primary key is one or more fields whose contents are unique for each record. So we'll go back to the database or table that we have now, but remember, that's either a single key or a combination of keys that uniquely identifies each record. So in our table, we need to remove repeating groups. We've done that, And now we need to remove non-atomic data, and I'll explain that in a moment, and then we can get to our primary keys. So non-atomic data is data where more than one piece of information is stored in the same field. So for example, asterisk minor, that's his name and his surname, appears in the name column. This would be much better to split it into a first name and a surname, because then I would be able to search easily for either surnames or first names in our database. So between these two tables, I've split the name field into two fields, a first name field and a surname field. And now I don't have non-atomic data anymore. Atomic data means that every piece of data in each of the fields cannot be broken down further. It's time to assign primary keys. So let's look at the data we have in this table and see how can we uniquely identify each record. So for example, the student ID definitely determines the name. So asterisk is dependent on the student ID because that student ID gives us all the personal details of our student. The same is true for the surname. Surname is also dependent on the student ID. English is definitely, or the description is definitely dependent on the subject code. And the mark seems to be dependent on both subject and student ID. So if a student takes English, then that would be the mark for that student. Symbol seems to be merely a different way of writing the mark. So symbol seems to be dependent only on mark itself. So for us to create a primary key that will uniquely identify any record, any row in this table, it looks to me as if we should use a combination of student ID and subject. And once we have those two, I can uniquely find any piece of information. So let's have a look. If I have this student ID, M0001, and the subject English, then I know that whatever mark appears has to be the English mark for asterisk minor. If I have student ID for Cleopatra and the subject history, I get a unique value for the mark for history for Cleopatra, and the same is true for drama. Once we've achieved first normal form, and this we have done here, if student ID and subject are the two primary keys, or form the composite primary key, the one that consists of more than one field, then we should write this table in standard form as, the table doesn't have a name at the moment, so let's give it a name, student details table. Primary key is student ID and subject ID. You can see that because I've underlined them. Next to student ID, I write the fields that are dependent on student ID, first name and surname. And next to subject, I write the fields that are dependent on it. So subject is dependent on description, and mark is dependent on both of those, student ID and subject. And symbol is dependent on mark. So this is the standard form for a table in first normal form.